Hello, I'm Paddy from Creative Media, and I've just fixed my Henry Hoover. Would you believe? Yeah, me, I fixed it. It wasn't working, and now it is. So I thought, sorry, I've got a cat in the frame here, and she thinks it's dinner time, but it's about 3 hours before dinner time, so she'll just have to wait. Yeah, I fixed it, and I'm going to show you how I took it apart, and what I checked, and how I fixed it. And I'm not really a professional fixer, but I know how to put on a plug safely, and I've fixed a few things in my time. So I was confident that I could take it apart and put it back together as it was, but I wasn't totally confident I could fix it. But I'm really chuffed I did. And this is my first brush with brushes in electric motors as well, so I can show you one of those and what it does and what it looks like. So first, getting the top off is lovely and easy. If you've got a Henry, you take this one off to change the bag. And off with the filter, yeah. Mine has a homemade bag. I just got fed up with throwaway bags, so I got some fabric, some fine fabric, which should filter out most of the dust. So I don't want lots of dust getting in the motor. And to be honest, I was a bit worried that it was my fault the motor had gone wrong because I'd made a homemade bag and I'd ruined everything. But I don't think my bag's to blame. My bag has some string. I just undo the string and I can tip it all out into the dustbin. You're going to get very dusty hands doing this as well, and worse later on as we go further into Henry's insides. Well, this bit is just the body, so we can put that away, out of the way, and concentrate on the insides. Now what I should say is the tools you need. One Phillips screwdriver is all you need. One with a plastic or a wooden handle is useful if you're getting into the electrical bits, which I'll explain later. You might find some kind of small chisel tip screwdriver useful as well, and you might find some needle nose or pointy nose pliers useful. Okay, so let's start taking things apart. Make sure your Henry is unplugged. Make sure you've actually got the plug in sight so you can tell for sure that it's not plugged into the mains and you're not going to get a nasty mains voltage shock. There are 1, 2, 3, 4 screws around the outside, so let's try those first. While I'm unscrewing these, the problem my Henry was having was it would turn on sometimes and other times it wouldn't, and it also sounded like it wasn't really running at full tilt when it was going. So I thought maybe there was some loose connection. That's pretty much as far as my electrical skills goes. Is it a loose connection or is it something worse that I can't fix? But I've learnt a few things in the process of doing this. Henrys are nice and simple. They're not overly complicated, which is a good thing. Some bits of equipment are just horribly complicated and they're full of electronic boards, and the electronic board goes wrong and you've got to chuck it away basically. The good thing with these is pretty much all the screws are the same. There's 2 kinds of silver screws in them, big ones and small ones, and not too many of them at that. So I can shake them out on the floor and make sure I've not lost them, and then lift this bit off to reveal a greasy bit here. See a greasy centre. Let's try and keep that clean if we can. And some greasy prongs here. This has got a kind of greased connection which allows it to turn around and stay in contact when you wind up and unwind the cable, if that's making sense. Well, this bit comes out, and this bit is where the wire goes, with that nice handle on the top which winds up all the wire.
Your power's a weak old man.
If you've got any kind of fault with the cable, then this is your chance to unwind it all. If your cable inside looks anything like that, or worse like this, you need to replace that cable. Having that going on inside or outside is bad news. Make sure you've got a suitably rated cable as well as a physically strong enough cable, because if you put a cable with basically the wire inside looks too thin, that wire will heat up. And since the cable's all coiled up inside Henry's head, that getting hot is going to cause problems. It'll melt and spark and bad things will happen. Yeah, it's easy to work out what kind of cable you need for Henry, because here on Henry's head it has got all the ratings, 1200 watts maximum and 230 volts. And this is the only equation I can actually remember from physics. Volts times amps equals watts. So if he's 1200 watts and 230 volts, then if he's got a 7 amp cable, that will make 1510 watts. So 7 amp cable would probably do, but probably 8 or 10 amp cable would be better. But I've noticed inside Henry, he only uses the neutral and live wires. He doesn't use the earth pin at all. So you could get away with using the kind of wire used on some kind of hedge trimmers and things, but make sure it's rated, yeah, kind of at least 8 amps, maybe 10 amps, and you'll avoid any risk of it heating up and causing a fire or melting, or even if just the outer bit melts, it'll mean you won't be able to kind of wind it out anymore. And I won't unwind this all because I haven't got a fault with the cable, but you can sort out any kinks in it and then put it all back together again pretty easily with just those 4 screws. If you've got a worse problem like I have with it not turning on at all, then you need to delve a bit deeper. So I'm going to put this aside and try and keep the dust and dirt off it, because getting dust and dirt into this bit here is not a good idea, because dust and dirt tends to be flammable and electricity is good at setting flammable things alight. So you don't want that in there catching light and bad things happening. And also it'll just be less smooth, it'll kind of grind and not turn around as well. Now my suspicion is these switches, maybe there's a problem with the switches, the connection there, which is why it turns on sometimes and not other times. Now here's a bit of genius Henry design. This switch cover here just comes off with 2 clips here and here. Clip, clip, just a bit of bendy plastic. There we go. And here, is that in focus? Here are all the connectors. Now what I was kind of hoping to find was that maybe one of these had just fallen off. This is where your chisel tip screwdriver might be useful. You could kind of slightly lever these off. And here's where my plastic handle tip comes in. A lot of electrical devices have capacitors in. Basically they hold charge even when the plug's unplugged. Only a small amount of charge, but it's a large charge for a short time. So what I do when I'm working with anything electrical and I see mains connectors like these is I hold on to the plastic handle of my screwdriver and just touch together where I can any contacts before I actually touch them with my hands, because that will dissipate, if that's the right word, dissipate the any voltage that's being held in any capacitors, and you can get a nasty, when you touch them you can get a nasty shock, which probably won't kill you, but best not to take any risks. A couple more tips actually working with electrical equipment. Some of these may be superstition, I don't know, but dry hands is definitely an advantage. Wet hands are more conductive than dry hands. Wet anything is more conductive than dry anything. So keep your hands nice and dry. You don't want to be getting water inside your Henry anyway. And also, if you're going to touch something that you're a little bit worried about, obviously take all the other precautions and checks first. But if you use your left hand first rather than your right hand, your left hand is further away from your heart. So if you do get a shot coming up your arm, it's got a better chance of missing your heart than your right arm. I looked at my plug here. I've actually took these switches out. They're quite easy to take out. Chisel tip might help you there. You can push these little springy bits here, and actually this switch will lift out with a bit of levering. Don't know if you can see that, but yeah, you can get the switch out fairly easily. And if you needed to replace the switch, if there was a fault with it, or if you'd actually physically damaged it and it wouldn't switch anymore, or it's stuck or something, you could do that this way, and that comes out really easily. It just pops in, clicks in like that. And if I'd seen any blackening around these contacts, I'm not really showing you these very well. If I'd seen any blackening around these contacts here, that would suggest the electricity was arcing. So the connection had a bit of a gap, and there were sparks happening in here. If you hear any kind of crackling and buzzing around your switches, that might be what's happening. And you might be able to just scrape clean any blackening off them and connect them again. If the wire is damaged and melted and looking in the state, you probably have to get that bit replaced, or maybe just replace the little, these are called spade connectors. You might be able to just replace that. But yeah, the switch is the next thing to look at, because that's nice and easy to get into. And I'll put that top back on again. Have I got that the right way up? I don't think I have. That way up. Good thing with the Henrys is things tend to only go on the right way. If you try and put it on upside down like I was doing there, then it probably won't fit. So that's a good check there. Okay, so that wasn't my problem. My problem was further in. And as you go, just take any dust off while you're going, because the less dust inside, the better in a Hoover, apart from inside Henry's bag. That's the place for the dust to go. Okay, so I need to go further in. Now, to avoid getting all this gloopy lubricant stuff on my lap, I'm going to take the other bit and rest Henry inside that like he usually rests anyway. So I'll keep my lap clean, and I keep the connection between the mains wire and the rest of Henry clean as well. I know I need to get inside Henry's heart. So 3 more screws to go. And like I said, these screws are the same kind of screws as the other ones I've taken out, so I needn't worry about muddling them up. And I know all 3 screws are the same as each other as well, so that's brilliant. More manufacturers should make things easy to work with like this. Now I can lift this next bit off. There it goes. And some bits come flying out here. These are the ear bits that kind of clonk into the side to hold the black top Henry's hat basically onto Henry's body. So those need to go back in the right way up, but they're quite easy to fit, and we'll do that on the way out again. I'll put them aside. So this bit has come, whoop, watch out for those screws, keep them safe. This bit's come off. This is just a piece of plastic. And here is Henry's actual motor, which does all the sucking. This bit comes out as well. We'll take this out too. This covers up the covers up the wires. Where are the wires? Covers up these mains wires here. I guess that's just a good safe thing to do. Things are coming off everywhere now. So put this bit aside. That only goes on one way as well. There's a rubber top for Henry's motor, which I guess just stops some of the vibration and the noise. I'm managing to remember all this in my head, but if you're not remembering which order things go in, do write it on a bit of paper. Draw a little circle, put the screws for that bit in there, or say, far side, near side, that kind of thing. But I can remember which way up this goes. It doesn't fit upside down, it has to go on that way. So that's nice and easy. Here is some more, I guess it's dust protection or noise protection or something. I remember that the top bit is where the wires go, so I'll kind of put that there. When I took this out, I shook it out a bit. It's a bit dusty, so I gave it a bit of a shake outside to to get the dust out. And this is the heart of a Henry. This is the motor. And again, take some bits, take the dust out as you go. Now the motor here just lifts out, but it is connected with wires, so be careful lifting it out. Oh, I've got a bit of hair in here, so I'm going to get my tweezers and remove that. I feel like a heart surgeon or something. It's brilliant. There's a hair. The heart of Henry. Out it comes. Now this, probably the most awkward bit was getting this back in, but it's not too bad really. So here is the inside of Henry's motor, and here's the kind of place where I'm going to be, maybe touching bits together a little bit just to make sure there's nothing sparky there. Now I do know a little bit about electric motors, and I know there are things called brushes which seem to be problems for people. And I know roughly what a brush does. Basically an electric motor is a coil of lots and lots of copper wire and some magnets and some electrical currents. And when you put the current through the coil of copper wire inside the magnets, it spins round and round. And of course it's much like the connection between Henry's mains wire and the insides. You need a kind of non-fixed connection between the electricity and the spinning bit, so otherwise it'll just twist round and round and snap. But with a motor it's obviously going a lot faster and a lot more often than just unwinding Henry's wire, so you need a really good connection which is smooth and doesn't wear out. So that's what brushes are, and these here are the brushes. They're not actually brushes like a toothbrush or something. They're actually pieces of graphite, which I've discovered through the process of doing this. I'll try and get this so you can see it. So I wanted to check what these things were doing, because these look nice and easy to take off anyway. So, undo these two, or one at a time. Now here's where you have to be extra careful not to drop things inside, because they'll be awkward to get out. So I'm partly undoing both screws, and then I'm going to fully undo one of them and take it out all the way. You might find your pliers or your tweezers useful here. Yeah, I can leave this other bit on and just pull this one out. Something's moving. So this is connected to the wire, connected to a wire, connected to the mains, and it's got a springy bit in it. So I can pull that off, I think. These spade connections, they just pull off. They're like a kind of slot thing. And there is my brush. It's a piece of graphite on a spring, and as you know, graphite, the stuff you get in pencils, is very soft. You can actually draw with this, and that's why my fingers are getting very black. And graphite also conducts electricity, so it's a perfect thing, because it's very smooth and soft, to rub against something that's rotating very fast. And as the rotating copper wire rubs against it and wears it down, the spring gradually advances it, so it's always touching. Now I took out both of these and had a look at them. The first one was just like that, it didn't spring out, and the other one did, so I thought, I reckon both of these should spring out, so why isn't one of them springing out? And I also checked the part number on these, because I thought maybe one of them isn't meant to spring out and one is, but they had an identical part number, so that made me think they should be acting in an identical way. And finally, as a check, I put them on some scales. I've got some very accurate scales, and they both weighed the same. So I thought probably the one that wasn't springing out like this should be springing out, but was somehow stuck. And sure enough, I got it, and I tapped it on the table, bat a few times gently, and suddenly, spring, the graphite block sprung out. And I thought that could well be my whole problem, that this end here that's meant to connect with the rotating copper coil is not springing out and not making a contact. So I was kind of right about my dodgy contact, wasn't I? Except it was in a much more complicated place than I thought of looking. I also slightly filed off the end of this one. How can I get it in the camera? Slightly filed off the end of this one because it was looking a bit rough. Because probably there'd been sparks coming because it hadn't been connecting properly and the electricity was having to jump across, which was causing damage to the surface. So I filed it a bit smooth and then put it back in again. And again, these are very handy. They only go in one way up, really. And you can also tell by you might not see on the camera there, you can tell by there's a curve going this way where it's been going against the rotating coil. So you can tell it's either that way up or this way up, and it will only go in this way up. And finally, the spade connection will only fit on one side, because that's where the connector is. So connect that one up. And put it back in. And you see, leaving one of these screws partly in has made things a lot more easy for me, because the bracket is already fitted there. That is fitting kind of properly. It's like it's got a little fixed bit that makes it stay in position. So I know that's in the right place. Let's do up my screw. Not mega tight, but sort of properly tight, because things are moving around here and you don't want things to get loose. There's an identical brush the other side, like I said. And as a final test, we can get the other side and make sure it spins around. That turns. There's a bit of a rubbing sound, I guess, from the graphite, but it's not kind of rough, so that's good. This is the last bit you could check. This is I think the only PCB, I don't know if I'd really call it a PCB or not, but it's got a component. It's got a few components. Don't know what that does. Some people would know, but not me. That's got some connectors on as well, so whoop. And I should do the usual, connect those with something metal with a plastic handle, just to make sure there's no sparks coming out of that. So yeah, you could check those aren't blackened, and check they're properly positioned and seated, and that just slots in here with a little bit of difficulty. There we go. That slots down there, goes in quite neatly and easily. Okay, so fitting this back in, got to be careful where these wires go. And these are the bits that stick into some holes, which are down here. Hole. It just rests there. That seems to be all it needs to do. So brilliant. First time that time. Took me quite a while to get that in previously, but now it's properly in. These white wires here go into some little slots in the plastic. Can I point to them? Yes, I can. There's a slot there and there. And then put back the this soft stuff. You can probably tell which way around it goes and where it fits, because there'll be a little dent where these little upright bits have gone, like that. Okay, that's good. And don't forget this bit. Just rest that on top of the motor. Now this bit and this end goes over where the electrical wires come in, so that's nice and easy. like that. It's quite an elegant point, that, isn't it, on the ends? I quite like that. I don't know why or what it's for, but elegant. Okay, which way around does this go? This only goes one way. Which way is it? Yes! Done it. That's it. That fits. But before I start putting in the screws, this is what I did before. Remember the ears from earlier on. They've got to go in, and they've got to go in the correct way up. These go in little slots. So those have got some slots there. And there's some sticky up bits. You see those here, basically, that these need to slot onto. That's it. And they go this way up. And the other side. That's in. Great. Okay, let's start doing screws up. And I hope I've got all of them. My tip with screws is to partially tighten them. So do one this side, and then do one this side. It doesn't really make so much sense with 3, but with 4, if you're going to do opposite corners or opposite sides partially tightened, if you do put in one screw and tighten it fully, it can sometimes kind of bend the whole thing up a bit like that, and then when you try to put the screw in the other side, it doesn't fit in the hole because it's got angled. This is like extreme, but so if you put in one slightly there, then you can just put one in there, tighten it up a bit, tighten that one up a bit, and then gradually kind of wriggle things down. It just helps avoid stress and avoids cross-threading screws and things going wrong. Okay, I'm going to carefully turn it over, holding everything together. Yeah, the cable has a slot to go through here, and on the end it also has this thing, the hole to go through, which you need to slot into Henry's head up here. Get that in camera. Just slides into the slot, very easy, but don't forget it. Henry's head. So line up this with the switches. That seems right. Make sure the turny thing will still turn. Turn the hole over, and then we can start putting in screws. Right. I've fixed it once today, but I really need to do the proof of the pudding and see if it really works again, having taken it apart a second time. So let's see. Now, which way shall I put his head on? I'm never actually sure. I imagine that Henry's meant to go over his face, really, isn't it? That's probably right, isn't it? Henry. So you could have it so he's got like his switches and stuff over his head. Or just have him randomly. Who knows? Let's have him that way round. Oh, I've forgotten to put his... What do you call this? His brain filter. Put in the brain filter. Good, he's all gone together. So let's plug him in and switch him on and see if he works. Yes! Victory! One repaired Henry. Thanks for watching.